My name is Coolant Cart, Vice President of Sales and Customer Service. I'm here to present our operation, maintenance, and calibration training class for our Malabar Coolant Service Cart for a 787 aircraft. The cart has various salient features and operating specifications that I'm going to briefly go through as a preamble to the course. The unit has an operating weight of approximately 4,600 pounds when it is fully serviced with coolant. The fluid that it uses is Boeing BMS 3-42 propylene glycol solution that includes an orange dye so you can see the visible fluid. The rated flow on the cart is up to 30 gallons a minute, and it's controlled with a variable control on the front of the cart, and we'll discuss that in a little while. The unit has an output pressure of up to 225 psi with a safety shutdown pressure of 230 psi. The unit has clean and waste reservoirs of 50 gallons each, and that is adequate enough to service the whole aircraft, which includes the power electronics cooling system, and also the integrated cooling system or ICS system, and the forward cargo air cooling system. It has supply and return filters to filter the fluid coming out to the aircraft and returning. The outlet is 3 micron absolute, and the return filter is 10 micron absolute. The unit uses a nitrogen as a source supply for purging the aircraft. After about 5,000 to 6,000 hours of operation, it's necessary to possibly purge the airplane, and we use low pressure nitrogen from a standard nitrogen bottle when that requirement occurs. Again, that's about 5,000 to 6,000 hours of operation. The onboard generator provides electric power where you don't have shore power, say you're out on the ramp. The diesel generator has an 8-gallon fuel tank and is adequate for several hours of operation. The unit operates at down to minus 40 degrees Fahrenheit up to 130 degrees Fahrenheit. Cart operators need to familiarize themselves with some of the possible safety hazards involved in operating the cart. One of them is a shock hazard. Because we're using high voltage electric power, you need to familiarize yourself with the safety features of the power panel. Make sure that you don't open the power panel with power on. You need to be aware of the plug on the end of the cable for plugging into the shore power, and the power generated from the diesel generator, again also high voltage 3-phase power. Before performing any work on the cart, it's necessary that you turn off the power before you do any maintenance on the electrical system. The propylene glycol fluid itself could be considered hazardous. However, it is non-toxic, and it's something you want to avoid trying to ingest. There is a compressed gas issue because you're using high pressure nitrogen from a nitrogen bottle. So you want to be aware of the hazards involved with using high pressure nitrogen. It's necessary to have a static grounding reel and cable when the cart is operating on the aircraft to make sure that you bond the aircraft to the cart. There is a rotating equipment hazard because it does have a motor and pump system. Although it is inside the cart, operation of that equipment, of course, you can access that, but you want to be careful with the connection between the motor and pump. Again, there's the pressure hazard from the fluid. Relatively low pressure, but be aware that you're using relatively medium pressure in servicing the aircraft. Again, up to around 225 psi. There are various safety devices and guards to assist in keeping yourself away from hazardous areas. One of them is the coupling guard that's on the motor and pump. The other one is the fan guard that's on the diesel generator set. There's also a battery cover for starting the generator. There is the electrical disconnect switch that's on the power box in the front of the cart. There is an instrument panel latch, and also there's a pressure switch which you have access to in a maintenance type function. There's also an emergency stop push button that is also on the panel in case there's an event that you can immediately shut down the cart. Finally, there are relief valves in case you do have a pressure switch that malfunctions or any other system component malfunction. There are relief valves to protect the system, of course, as well as the aircraft. There are various warning labels that are fixed to the cart as a reminder of those areas that you should be aware of when you're working on the cart, especially in a maintenance function. Those include your electric hazard warning labels, which are on the front of the cart. There's also a warning label which is in the enclosure with the access panel open to keep the aircraft approximately 5 feet away from the cart, out of the envelope of the aircraft. Primary reason, of course, is the aircraft has fuel aboard and you need to keep the cart 5 feet out of that envelope due to the possible hazards involved with fuel. Lastly, the generator, of course, has various warning labels, including hot gases from the exhaust, electrical power, of course, and rotating machinery, the fan, and the battery enclosure. Next, we want to talk about the system of operation on the cart and the various control features that are included in the cart. The cart is designed to fill, clean, deaerate, bleed, and evacuate the aircraft when it's time to change the fluid. The CSC cart is designed to fill, clean, deaerate, recirculate, and preheat the coolant fluid that's to be used on the 787. The various components are used in the cart to control these various functions. The control panel provides the primary operator interface for the cart. Located at the rear of the cart, it has the electrical controls displays mounted on the hinged door of the main control enclosure that houses a PLC, control relays, interconnection terminal blocks, and a low ambient temperature sensing and heating system for the electronics. The control enclosure is located in the center section of the panel. Located on either side of the control enclosure are illuminated sight glasses for monitoring fluid aeration and purge, drain status, nitrogen regulator, fluid fill and purge control valve, and various vacuum, pressure, temperature, and fluid meters. The clean reservoir has a 50-gallon usable capacity and a stainless steel cylindrical tank equipped with a level gauge, Rochester type, a fill port and strainer cap, a drain valve, a pump suction isolation valve, a temperature sensor, a vacuum and pressure relief valves, as well as a thermal blanket to keep the fluid warm and for storage, of course, clean fluid. The unit includes a supply filter and valve assemblies, which is on the supply side of the cart. It's a manifold system with a filter and valves on the pressure side with a fluid circuit designed to minimize fluid connections and piping. There's a 3-micron absolute non-bypass type filter with a differential pressure switch in the supply line downstream of the pump. All directional valves have stainless steel bodies, Viton seals, and are 24-volt DC solenoid operated. In addition, there's a solenoid valve in the manifold block labeled SV1 for sampling. The waste reservoir is a 50-gallon usable capacity stainless steel tank equipped with a level gauge, a fill port, strainer cap, drain valve, and center breather, which is provided for collection of fluid purge from the aircraft systems. The vacuum pump system consists of a 24-volt DC motor-driven vacuum pump, a trap, and a muffler with a vacuum regulator. These are provided to apply a vacuum to the reservoir for deaerating the fluid, preset at 3 inches of mercury. The return filter and valve assemblies are manifolded on the return side of the fluid circuit, which are designed to minimize fluid connections and piping. There is a 10-micron absolute non-bypass type filter with a differential pressure switch in the return line. All directional valves have stainless steel bodies, Viton seals, and are 24-volt DC solenoid operated. There's also a sampling valve, SV2, for sampling the fluid returning from the aircraft. A two-stage internal crescent-type gear pump is close coupled to a 10 horsepower, 208 to 240 volt, three-phase, 60 hertz volts. It's a NEMA C-face motor, totally enclosed, fan-cooled. There are two accessory storage boxes located underneath the main enclosure between the forklift pockets. The storage boxes provide a storage for all the necessary adapter fittings, bleed hose, and accessories for interfacing the cart to the aircraft. Supply and return hose assemblies include each with a 30-foot long synthetic rubber covered conductive hose with flush type couplers and nipples installed at each end. The return hose includes a QD nipple, and the supply hose includes a QD coupling. This permits coupling of the supply hose to the return hose to allow operation in a runaround mode to precondition the cart fluid or flush the cart system. Model 1011A has a diesel generator set for self-contained operation. The generator includes an 8-gallon fuel tank located just above the engine. The fuel gauge is located in the top of the tank. The unit includes top-off LRU, which stands for Line Replaceable Unit, supply and return hose assemblies. These are 30-foot long, 3/8 synthetic covered conductive hoses with Parker flush face, couplers, and nipples. There is a supply and return hose, and they are located as shown in the front of the cart next to the tow bar. There is a 100-foot cable. The rack is located just above the generator and is designed to store the cable and mates with a facility power receptacle. The receptacle is provided by the customer. The static ground rail is used to bond the cart to the aircraft grounding system during servicing. The coolant service cart is designed to service various cooling systems on the Boeing 787 aircraft. The system circulates BMS 3-42 coolant through the systems, filters it, deaerates it, and drains it. The cart can also be used to service individual aircraft system LRUs. The CSC unit uses a two-stage internal gear pump driven by a 10 horsepower electric motor to circulate coolant through the cart and the aircraft cooling systems. The unit is powered by a line cord or a water-cooled diesel generator. The pump draws coolant from a 50-gallon clean reservoir and sends it through a 3-micron supply filter. From the filter, the coolant flow is directed by a selection of solenoid valves based on aircraft subsystem being serviced and or cart mode of operation through a flow meter, sight glass, and main supply hose to the aircraft or return hose in the runaround mode, or two through LRU sight glasses, LRU supply hose, through a recirculate solenoid valve to the return line, or the pump relief valve in a preheat mode bypassing the filter. Coolant returning from the aircraft system re-enters the cart through the return hose. Solenoid valves direct the fluid to either the clean or waste reservoir. Sight glasses monitor fluid condition in each circuit. The flow path to the clean reservoir also includes a 10-micron return filter. A complete set of adapter fittings is provided for connection of the hoses to the appropriate points on the aircraft. The entire coolant loop is protected from overpressure by a factory preset relief valves and pressure switch. The clean reservoir on the cart is connected to a 24-volt DC vacuum pump and vacuum regulator that will maintain a vacuum on the clean reservoir to deaerate the coolant. This regulator is factory set at 3 inches mercury vacuum. The vacuum pump is controlled by setting the vacuum regulator located above the clean reservoir. CSC operation is controlled by an Allen Bradley Programmable Logic Controller, PLC, in conjunction with a variable frequency drive, or VFD, relays, selector switches, sensors, and other devices. By controlling the VFD pump, motor speed, and numerous solenoid valves, the PLC controls the flow of coolant through the CSC and the aircraft. For each position of the mode selector switch, the PLC system is pre-programmed with the required flow rate, or motor speed, and valve configuration. The PLC system also monitors fluid levels in the 2 reservoirs, fluid temperature, and filter differential pressures. The flow sights are panel mounted and illuminated. One is located upstream of the flow meter in the supply line, one in the return flow line to the clean reservoir, one in the drain line to the waste reservoir, one in the clean bleed return line to the clean reservoir, one in the waste return line to the waste reservoir, and one in the top-off LRU or line replaceable unit supply line. A status beacon and audible alarm is provided on the top of the cart. The green, yellow, red stack beacon is located above the control panel to indicate unit status. Green is power on, flashing yellow is caution operating, flashing red is unacknowledged alarm. A fault steady red acknowledged alarm. An audible alarm located in the top of the stack will sound when an alarm occurs, silence from the operator panel. The main power disconnect switch is located on the electrical enclosure below the power panel. The power panel hoses the main disconnect switch for all 1010A and 1011A models. In there includes the variable speed pump drive, a 24-volt DC power supply, and a low ambient temperature sensing and heating system for the electronics. LRU out and in connections are on the corner of the cart. The nitrogen purge system is located on the front panel and includes the nitrogen pressure gauge, nitrogen regulator, and the nitrogen connection. The nitrogen connection will withstand up to 3,500 psi nitrogen inlet, and the regulator will regulate it down to 100 psi. The CSC cart must be properly located before operation. The cart should be located so that the power cable can be readily connected to the facility power outlet in the electric mode, and the supply and return hoses can be readily connected to the appropriate points on the aircraft, or in this case in the runner mount mode for initial operation. The CSC cart must never be located within 5 feet of the aircraft envelope. Before operating the CSC, the supply and return hoses must be fully removed from the cart and uncoiled before operation. The hoses are 30-foot long synthetic rubber covered conductive hose. The supply hose has a male quick disconnect coupler on it, and the return hose has a female quick disconnect nipple. Prior to operation of the cart, the hoses must be connected in the runaround mode. Never at any time should the hoses be disconnected in an attempt to run the cart, because you'll trap pressure in the hoses, which will make it very difficult to connect. The CSC cart is controlled by 8 modes of operation. In addition, you have flow rate adjustments and timer countdown adjustments on the panel. You also have a lamp test, and you have on-off switches for the master, vacuum, on-off, timer, on-off, waste or return select, mode run or mode off. In the preheat mode, the default setting is 20 gallons per minute. In the de-aerate mode, default setting is 30 gallons per minute. In the runaround, it's also 30 gallons. Remember, runaround is with the hoses connected. LRU fill is at very low flow because the components are relatively small, and the LRU flow goes through the LRU supply fluid flow site. System fill, default setting is 4 gallons a minute. Not any higher for an empty airplane, because you don't want to water hammer the system with a high flow rate with an initial fill. System clean, default setting is 7 gallons per minute. For the ICS, a placard on the panel displays the different recommended flow rates. ICS 7 GPM, FCAC 15 GPM, and PEX 32 GPM maximum. We'll adjust those flow rates to describe how that works in a minute. We also have N2 purge. There is no flow rate here, and that basically directs the nitrogen inlet through the supply hose out to the aircraft and back in to empty the aircraft into the waste tank. It's already pre-selected in waste, and you can't go back to clean. That's so you don't contaminate your clean tank. You also have N2 purge if you want to purge an LRU, again to empty an LRU to send it back to the manufacturer for repair or warranty action. So we're going to start with a normal operation. Say you're in a temperature environment below 65 degrees Fahrenheit. So you go to the preheat mode, selected at 20 gallons per minute. However, if temperature in the reservoir is below 30 degrees, you don't want to go any faster than 30. 20. If it's above 50, you can go up to 25 GPM, and you can adjust it by hitting the flow and increase, and you can increase the flow to whatever set point you want. I'm going to stop at around 25. So I'm going to start this to demonstrate the noise level in the preheat mode. The preheat mode actually is heating the fluid going over one of the system relief valves. We hit start. The motor ramps up through the VFD and is actually running that fluid back from the clean reservoir back into the clean reservoir to heat the fluid in the clean reservoir. And you monitor your temperature right here in your reservoir. It raises about a degree per minute at about 25 to 30 gallons a minute. So that's one operation for preheating the fluid. Again, when the fluid is below 65 degrees Fahrenheit. So we can hit off and stop that mode. Now, if we want to recirculate the fluid, this is more of a maintenance function within the cart. I haven't run any fluid in the hoses yet. I'm going to go ahead and start it and at 30 gallons. And again, it's recirculating in the clean tank, which is the normal default setting. That's internally. You're not going to see any flow rates here or anything like that because you're bypassing the turbine flow meter. So that's internal. It's more of a maintenance function to see that everything's operating properly without the hoses in the circuit. Now we'll demonstrate runaround. In this case, you'll actually see fluid coming out of the supply line back into the return line. So in the runaround mode, again, we start with a flow rate starting at 30 gallons a minute, and we start seeing fluid go through the supply sight gauge here, and then coming back through the return flow. Now what we want to monitor is any air that might be in the hoses. So you'll see a lot of bubbles in here in the return flow sight because those hoses were empty in this particular case. And you can see it's very cloudy. So to assist in deaerating that flow rate, that getting the air out of that return flow, you turn on the vacuum pump, and that'll assist in deaerating the fluid faster. The cart has a timer function that allows it to count down automatically and shut off. I'm going to adjust the time from the default setting of 2.3 minutes by holding down on the time button and the decrease button. Now you notice I'm doing this on the run, which is perfectly okay. I'm just going to shut it down a little quicker. Okay, now I'm going to turn the timer on, and you can see after 0.50 minutes it's timing down. Now once this times out to 0, it will automatically shut off. Now there's an important function to understand about this timer, and I'm going to demonstrate it in a minute. 8, 7, 6, 5, 4, 3, 2, 1, 0. Shut down. Now there's an important function about this. You notice the timer is flashing. Okay? I'm going to try and restart this, and you notice it won't start. No matter how I try, it will not start because the timer is set at 0. So what we want to do is turn the timer off, then we can start it with the timer off. And if I turn the timer back on again, it'll count down again. So that's how the timer works. If you want to process an airplane and you want to go have a sandwich or a cup of coffee and you want to set it up for maybe 5 or 10 minutes of operation to clean out an aircraft and deaerate it, you have that opportunity. It'll shut down automatically. So we've demonstrated runaround, and we've got the air out of the hoses by operating it for a few minutes. It doesn't take much time. And now I want to demonstrate system fill at a lower flow rate. Now we're going to simulate that the hoses are connected to the aircraft. Now I'm going to demonstrate from runaround to system fill. And the default setting is 4 gallons. Now, before I start, if I want to go a little bit faster, I hit on the flow setting, on the rate, and I can increase it from 4, and you notice it starts counting up. 5.7, 6.7. You wouldn't want to go any faster than that. I'm just showing you how you can adjust it, and then we'll start, and I'll show you how you can decrease it. So I hit on, and it's not going to make much noise because it's going a relatively low flow rate. So now what I'm going to do is I'm going to put on the flow set point and hit decrease, and you notice it's going back down again. So you can adjust the flow rate, operator, however you want to do it. So that's back to close to default setting. System fill is always about the same no matter what system you're filling on the aircraft, with the exception of LRU, which is, those are line replaceable units. The next set point default, and you notice it goes off. The next one is 7, so I turn it on again. Now it's going to start, and it's going to feed back that 7 gallons, and it's actually running at about 7.3, 7.2. It'll hunt back in as it feeds back from the turbine flow meter. So I'm going to hit flow again, rate, and if I want, that's ICS. Now I want to change that. I want to change that to FCAC, which is your forward cargo air cooling, which is preset at 15 gallons, and you can hear the noise increase. So it's that 14.9. I want to change that. I'm going to go down. I overshot. You can adjust it back down again. So that's the set point that's recommended for FCAC. Now, if I want to increase the flow rate for your bigger systems, your power electronic cooling systems or PEC systems, again hit flow and increase it. And the longer you hold it down, the faster the increases by a gallon. So there's 29.8. Again, we're simulating that we're cleaning the system or de-aerating the system because we don't have the hoses, in this case, connected to the aircraft, which is not standard. But anyway, you have to demonstrate it, so you need to connect the hoses together for this demonstration. We also have alarms that indicate various functions on the cart. I've induced a fault with a low fuel indication, and we'll talk about clearing that in a minute. But you have high level waste tank, you'll get an alarm and a shutdown if the waste tank is too full. You have a low level clean tank, which means you don't have enough fluid in your clean tank, and it will be a shutdown until you put more fluid in the clean tank. You have high delta P across your supply filter. Remember, that's on this side. And then you have high delta P on your return filter. That differential pressure is actually 25 psi-D. That's the set point where you get an alarm. It's not a shutdown, it's a warning that it's time to change the filter element. You have a high temperature alarm. It's not a shutdown, it's a warning. You need to stop and cool it down by recirculating. You have a high pressure shutdown warning. That's if the pressure goes over the set pressure switch setting of 230 psi, and that's a shutdown, and you'll have to clear that high pressure. In the case of a low level, you're going to get this action here. I can actually run the cart. I can still run the cart, but it's a warning, okay, on the electric side. Now, to clear this alarm, I've acknowledged I'm going to try and reset it. It won't reset. We still show the alarm, but I have to reset it. I'll acknowledge it, and I hit, oh, the alarm is clear. Reset. We have an emergency stop push button. If there's any time that something goes wrong and you want to stop the operation, you hit that emergency stop. Everything shuts down. The way you reset the stop, the way the arrow shows, you go like this, and it resets. But you notice that the master switch is still flashing, indicating you're going to have to reset it before you can start it again. So that's how the emergency stop button works. You also have an hour meter on the panel. This tells you how many hours you run with the motor running, not with it on, but with the motor running. As I said, we've seen the generator in the back, but there is a generator control panel, and I'll point that out in a minute. You have your temperature gauge, you have your return pressure gauge, you have your supply pressure gauge, and then you have your vacuum gauge, and then you have your top-off LRU supply pressure gauge. Your flow sites are all listed right here, and we'll demonstrate a purge so you see how that works in conjunction with the N2 purge supply and N2 LRU purge. We're going to simulate purging the aircraft using nitrogen. We have a connection here with nitrogen, and we have the N2 supply pressure mode select switch, what we're going to use to purge the aircraft of nitrogen back into the waste tank. Now if I go to N2 purge on the supply, you notice the light comes on in waste, not to clean. There's jump out lockout wires in here that doesn't allow you to go back to clean. We do have, and we'll discuss this in the preventive maintenance section about those wires a little bit later, but suffice it to say the default setting always goes to waste because you don't want to contaminate your clean reservoir with waste fluid coming from the aircraft. So I have nitrogen supply selected. I have nitrogen on the cart. I'm going to move it up to a starting pressure of about 50 psi nitrogen. So that's where you want to start. So then I could go ahead and I can start. Your flow meter is not going to do anything. Your timer, what you're looking for is to get the fluid out of this line. So I'm going to turn that on. And what that's going to do, that's going to push that fluid out of the hoses, and it's going to come back into the waste tank. So that illustrates how you use nitrogen to purge the aircraft. Again, we're in a simulated mode right now with the hoses, but as soon as this runs clear, you've cleared the aircraft out with fluid. And we'll let it do that. You're never going to get it all out but on these glasses, but the hoses are clear. So that's how you purge your main systems on your aircraft going through the N2 purge supply. And again, by shutting it off, you shut it down, and you're finished. So that's illustrates your N2 purge on supply. So we're going to demonstrate filling an LRU. And I'm going to demonstrate that by going in the LRU out connection here on the cart and coming back in the LRU in connection by coupling these hoses together. This simulates going out to an LRU and back using one hose for this simulation. And I go over here to LRU fill. The preset is 2 gallons per minute. You don't want to go much higher than that because you got a small hose and you have a component that won't take a lot of flow rate in filling. So now I'm going to start. Notice I'm in the clean again, default. I want to be in the clean mode as a default because I don't want to waste any fluid coming back, especially when a LRU is empty and it's clean, it's ready to fill it. But that is the default setting. I can demonstrate that again by going back, and that's the clean setting. So now we're going to start, and we're going to fill this up, okay? And it's going very slow. Now it's getting the air, return flow, it's getting the air out of that hose. You notice this is your return, very small hose, so it's going to get the air out pretty quickly. Now I can adjust it a little bit by, again, going to the flow and increasing it. I'll go to 3. It won't let you go much more than 4. So that's 3 gallons a minute. Again, by operating the vacuum pump, that will assist because it's going back into your clean tank. The vacuum pump provides assist for doing that. Okay, now at this juncture, I'm going to stop. It's relatively full. So now we're stopping at LRU fill. Now, by the same token, if I want to purge that, like I've purged the aircraft, I can go into N2 purge. I put it in the N2 purge mode, turn the mode switch on, and I push fluid out of the hose, and again you see the drain flow with the fluid coming out of the hose. You're in the waste mode, which is default setting. So the fluid that I'm pushing out of there, again in a purge mode or drain mode, goes back into the waste tank, not in the clean. That fairly well cleans out most of the fluid in the line, so I turn this switch off, reduce my regulator, the nitrogen, and that basically shows you filling and purging using the cart. There are 4 calibration verification procedures for the coolant service cart: the pressure gauges, the temperature gauge, the pressure switch behind this panel, and the flow meter verification tool. For preventive maintenance on the coolant service cart, there are various procedures that are recommended. For each day of operation, on the vacuum pump and drain the trap if it's more than half full. Check the frame structure, fittings, fasteners, struts, and then tighten them as necessary. Visually inspect the coolant system components, valves, fittings, hoses, tighten or loosen or replace any leaking fittings or gaskets. Check the power cord for any damage, fraying, and replace as necessary. Visually inspect the hoses for signs of wear or damage. Check the parking brake and make sure that the brake locks are adjusted and repair as necessary. Check the instrument lamps through the lamp test button and check and replace any switches or lamps that aren't illuminated. Annually, inspect the wiring. Visually inspect electrical enclosure for loose wires, connections. Check all power terminals and screws for tightness. Annually, check and tighten all screws or wire terminals. Annually, inspect the electrical enclosure vents. Remove or inspect the 2 vent filters inside the power enclosure louvers. Clean the filters by blowing out the dust with compressed air, wash or with mild detergent if oily. Never blow compressed air around any electrical devices or in any electrical enclosures. Cabinet frame. Clean exterior surfaces. Use mild soap and with sponge or soft cloth. Do not use abrasive cleaners. And remove all cleaning agent residue. Cabinet interior and drip pan. Remove debris from inside the cart enclosure using a vacuum cleaner. Wipe up the drip pan clean. Steering mechanism. Lubricate. Parking brake, lubricate. Wheel bearings. Lubricate only when necessary, if rarely towed. Calibrate the gauges, as we've just discussed about annual calibration procedures. On behalf of Malabar International, we are pleased to have presented our operation, maintenance, and calibration on the coolant service cart. For additional information, please consult your owner's manual or contact us at malabar.com for additional information or assistance. Thank you.